Hi there, my name is Jeffrey and this is another video in the NSX Fundamentals series. So in previous videos we covered logical switching, logical routing, load balancing, HA, DHCP, but there's one really big topic missing in that series, which is of course microsegmentation. Now this is a very important topic because many companies buy NSX specifically to do microsegmentation. And yes, this can get really complex and really deep when you want to implement this on the most granular level, so on the application level, inside of large data centers, large enterprises. But it is a very powerful feature, and the core concept is not really that hard. So in this video, I'm going to explain what microsegmentation is, what benefits it brings opposed to the traditional approach of doing segmentation in the network. And we're going to, of course, dive into my homelab environment where we will do some basic microsegmentation policies. So you understand how you can apply the rules and the policies inside your own environment. So let's dive right in. So let's first go over the basics. And before we can dive into how we can solve network segmentation inside of NSX, it's good to work our way back through how we used to do network segmentation in the data center and how a typical security model would look like. I think the best analogy that's often used around explaining microsegmentation is looking at traditional security as a castle and moat type of security. So the castle is of course your data center and you protect it with that moat around your castle. Your castle is well guarded. It's well protected from the outside world. But as soon as you are inside of the castle, there's perhaps not a whole lot of protection anymore. There might be some rooms where you're not allowed to go in because there are guards standing outside. But basically, when you are inside of the castle, you're free to roam wherever you want. Now, if you kind of compare that into a very simplified visualization of how we do segmentation in a traditional data center, depicted on the left-hand side here, you will see that, typically we would have that big perimeter firewall protecting us from the outside world. So that's our moat. This will do all the fancy security stuff. So deep packet inspection, layer 7 stuff, URL filtering, all the fancy stuff that we really need to protect us from the big bad world. Then we have a demilitarized zone, the DMZ. This is where you would typically put some front-facing or customer-facing or internet-facing applications, web servers, proxy servers, stuff that needs to have connectivity to the outside world. Then you would typically have one or more firewalls inside of your data center to segment your VLANs. All the network segments in your data center are typically VLANs, so virtual LANs. Now these virtual LANs are all being routed through a layer 3 device, which typically would be an internal firewall or a layer 3 switch where we do filtering with ACLs, etc. The big challenge is that this model really worked very well because in the past, because most of the threats came from the outside world. Most of the malicious activities were initiated from outside of your trusted network. They came from hackers trying to find vulnerabilities on your perimeter firewall. They tried to attack your VPN appliance, and so on and so on. What we nowadays typically see is that the majority of the cybersecurity threats originate from inside of your network. It's typically a user that gets tricked into clicking a malicious link in a phishing email, or plugging in an infected USB drive into their laptop. So what we really quite often see now, and the statistics show it, is that really the majority come from inside of your network. And I've seen customers where, the Citrix farm was sitting in a network where the application servers were also being hosted. So there was no layer 3 protection at all between the clients, in this case the Citrix servers, where all the users were working and opening email and doing stuff, and the application service and even database service sitting in that same network. So any malicious code, any malicious software was free to roam east-west or do lateral movement inside of the data center without any limitations. And that's a big problem nowadays, especially with all the ransomware attacks going on. So whenever a system is compromised, you typically want to limit the blast radius of that incident. So now with NSX, we can do segmentation on a whole different level. So as you can see here, with distributed firewalling, every virtual machine will get its own dedicated virtual firewall. So if we take a simplified look at how a bunch of networks are connected and segmented in a traditional setup. So here we have a kind of a production environment and we have a dev environment. Now I have three networks, as you can see. I have my web network, an application network, and a database network. A very typical three-tier network segmentation. Now, in order for the web server to communicate with the application server, there needs to be routing in place, of course. Now, typically what you would see is that traffic would be routed by an internal firewall. So this is, again, a very simplified version, very much zoomed in into a specific part of the data center. But this firewall would typically contain firewall rules to, for example, prevent the web server from directly accessing the database. That's typically not what you want in a three-tier architecture. But as you can tell, let's say that this web server is compromised, and that means that there's no protection, because this is a layer 2 segment. There's no protection whatsoever between web server 1, web server 2, and all the other web servers inside of that network, of course. And the same goes for the development environment, of course. So the same security risks are inside of every environment within your data center. And what's to say, because maybe you are allowed to push code from your web server to the production environment. Let's say you have a software deployment solution there. So once stuff gets developed and approved, you can push your code into the web server. So there are ports open there. Or maybe there is an FTP server that allows you to upload files from the dev environment into the production environment. If a part of your network is compromised, then the risks are really big, because without proper segmentation on a granular level, there will be malicious software going freely within your data center, or what we call lateral movement. So how would we protect this with NSX? Now with NSX, you will get a distributed firewall functionality. So this is a kernel module which is running on every ESXi server that's part of the NSX-T environment. So what this allows us to do is to, from a single management plane, from a single control plane, protect all these applications or all these virtual machines using the distributed firewall. Now in this case, if my web server, this typically has no function, or there's no compelling reason for this web server to be able to communicate with the other web servers in the same segment. What you would typically want to do is kind of isolate these web servers from being able to talk east-west or laterally with each other. So with microsegmentation and the distributed firewall, we can now isolate this web server from all the other web servers on this same layer 2 segment. So nothing is actually hitting a physical wire here. So let's imagine that these two virtual machines are running on the same ESXi host, on the same physical host. There will be no packet hitting the physical wire. But nevertheless, we can set our policies, and we can protect web server 01 from web server 02 by not allowing them to talk to each other. We can set policies that allows us to kind of make sure that traffic always traverses the desired tiering model. So allowing Web 01 to talk to application 01, but we don't want the web service to talk directly to the database server, of course. So this way we can do really granular micro-segmentation. Now this brings up a sensitive topic because this can get very complex in large-scale environments. Imagine you have hundreds or even thousands of virtual machines running all types of applications, and if you want to go towards a zero trust architecture where no traffic is allowed unless you specifically permit it, then it can get really complex really fast. So you need software like vRealize Network Insight, for example, which I won't cover in this video, that will allow you to make an assessment and an inventory of all the network traffic that's going and all the flows going on in your data center. But again, that's a bit of an advanced topic. So for microsegmentation, let's start with the basics. And for example, I will show you now in the homelab environment how you can very easily prevent all the production servers from talking to all the dev servers and the other way around. Let's go into the homelab now and let's see how this actually works. All right, let's take a look at the environment and then we'll dive into the distributed firewall. So this is of course the NSX manager, but let's look at the demo environment. So I have two very basic, applications running, and I have a simple 3-tier application to demo. So this is just a very simple web front end with a bookstore demo, and I have a number of production virtual machines. So this is basically my DevTest environment, and this is the production environment. So these are all simple Linux machines. And as you can see here, this is the front end. So that's 10.0.100.11. That's working. And for some reason, the bookshelf application is not working in the quote-unquote, I guess, production environment. But as you can see here, there's an Nginx web server running. So we can test our microsegmentation rules. Let's take a look at the topology inside of NSX. So let's go to the network topology. And here you will see, this will take a minute to build up. So let me see. So this is the DevTest environment. As you can see, this is running on an overlay segment. Database server 1, the database servers. So these are the dev environment and the prod environment are connected to the same segment. That's not a problem, of course, because we can now do segmentation with the distributed firewall. So we can mix and match production and DevTest environments on the same network segment. Here we have the, let me check, this is the web tier, so 4 virtual machines, and this would be the application tier. So it's being routed by the tier 1 gateway, the tier 1 gateway is connected to the T0, and this is connected to my quote-unquote top of rack switches. So this is a fully nested environment. Check out my other video on how I build this stuff in the home lab. But for now, we're going to focus, of course, on the lower part. And this reminds me that one of the biggest misconceptions with NSX, when I talk to customers around the microsegmentation use case, is that many customers think that you need to have this whole topology set up. So you need to have the overlay segment in place. You need to have the logical routing in place, etc., etc. That's not the case. Let me re-emphasize. You do not need to do logical routing and switching if you want to do microsegmentation. Even more so, many customers buy NSX just for the microsegmentation capability, so for the distributed firewall. So VMware even released a new bundle or a new SKU of NSX, which is called NSX Security, which in its basic, on the basic level, it only allows you to do the security stuff, so microsegmentation, but that's at a fraction of the price of what a Enterprise Plus license costs of NSX. So the complexity is not really there. There's a wizard inside of NSX in the manager. So prepare clusters for networking and security. This is a 5-minute task, and that's it. And you could do microsegmentation. So I really wanted to emphasize this because, again, this is a really big misconception in the market. So let's take a look at the distributed firewall itself. So this is basically how any firewall works, right? So we have kind of categories that are that you can use to kind of group and prioritize your policy rules. We have an emergency category. For example, when there's an issue or security incident, you can very quickly isolate, the part of the network that has a security issue, and this goes from priority from left to right, of course. So first, the Ethernet category will be processed, then the emergency, then infrastructure, then environment and applications. So anything you put inside of the emergency category will be prioritized. And it also works the other way around. If you're doing a microsegmentation project and maybe you blocked something unintentionally and you caused an incident or a disruption inside of your production environment, you can very quickly open up temporary traffic by using the emergency category. Next up in this hierarchy is the infrastructure category, where you would typically see your domain controllers, your NTP servers, all kinds of network services that you can think of. You can define them in groups, and you can add your members, and then you can put them in the infrastructure category. After that, we have the environment category. So this could be production and DevTest, like we had in our little use case. But this could also be tenant 1 and tenant 2. This could be finance, HR, etc. You can be very creative here. But these are kind of your macro level segmentation rules. And then on the most granular level, you have the application category. And this is where you do the actual microsegmentation on the application level. Now, as with any typical firewall, there is a default layer 3 rule, a kind of a catch-all rule. And I've placed this now into the allow action. So typically when you have your entire microsegmentation rule base set up, then you would typically set this to block. And that will make sure that any traffic that you haven't specifically regulated inside of your policy rule base, that will be blocked. And this is, of course, a very big step. So let's go over our little environment. So let's start with the infrastructure layer. I have a domain controller rule in here. So let's see how this works. You can add a policy, and inside of your policy, you can create rules. Now, how do you typically create a rule? Well, let's say that I have, so this is a test rule, of course. So my source could be, I now have any in there, but this could be a security group, or this could be an IP address. Now, what is a security group? A security group is a construct inside of NSX. So you can set membership criteria in a number of ways. I won't go over every option because then this video would be way too long, but let's go over the most common options. So you can say that, for example, virtual machines that have a specific tag assigned to them are a member of this group. So let's go back to our little use case. Let's say that I want to tag every virtual machine with the DevTest tag, then that would automatically make the virtual machines in the DevTest environment a member of this group. Now you can do a bunch of other stuff, like you can define IP sets and you give them tags, you can define virtual machines, and you can define membership on computer names or OS names, or let's say that you want to open up, for example, RDP to all your Windows servers from your management segment, or SSH for all your Linux machines. That you can do stuff with the operating system, for example. Now you can also do static membership, where you simply do nesting of groups, but of course you can also select statically virtual machines. Now this is not a very dynamic way, of course, of doing stuff, so I won't recommend this too much. Typically customers would start with security tags, which is a very easy way to kind of dip your toes into microsegmentation. So this is a simple rule that says any source can talk to my domain controller security group over any service. So this basically guarantees me that all my virtual machines can talk to the domain controllers because they also host DNS, DHCP, etc., etc. Of course, in a production environment, you would want to narrow that down, but in my homelab environment, this really suffices. Now let's hop over to the environment section. And this is where I have a policy that prevents DevTest from talking to anything that's not DevTest. And production, kind of a typo here, it blocks any traffic going from production to everything that is not production. So what does that actually mean and how do you set this up? So I use a negate selections option here. So this means that I will invert or negate the selection. So here I can say everything that is not DevTest. That's basically what this says. So DevTest can only talk to itself, because all traffic going to everything that's not DevTest will be dropped in this case. So same goes for production. Production can only talk to itself. So all the production machines can only talk to production machines, because as soon as a production machine wants to talk to a DevTest machine, then that traffic is blocked, because I have a negated selection here that says everything that is not production. So this is very coarse. But this already provides so much value for many companies, where you can now very easily do not microsegmentation, but macro-segmentation. So even, I talk to so many customers, and once you're inside of the data center, once you're behind the perimeter firewall, then you'd be surprised how many networks are so badly segmented. So there's so many different machines that are very easily attributed to different environments that are just able to talk to each other. So that's a really security risk. And by only implementing these very high level macro segmentation level, that can already bring a big value in terms of improving your security posture. But of course, if you really want to drill down to the application level, then you go to the last category, and here you would add different policies, like this one, for example. So I have a 3-tier application. So what I say here is that every database server cannot talk to any other database server. So, and think about it, if you're a database server hosting databases for a number of applications, and there's another database sitting on that same virtual wire, on that same segment, but that's hosting databases for entirely different applications, why would these database servers need to talk to each other? And the same goes for application servers and especially web servers. If these are, for example, running in a DMZ and one of your web servers gets infected, again, you want to limit that blast radius. So presentation or the web tier cannot talk to any other server inside of that same web tier. So this is microsegmentation in its purest sense, because these could be virtual machines sitting on the same VLAN or the same segment, and you can segment them, you can isolate them from each other. And this is revolutionary technology that NSX brought to the market. Now, let's take another look at the firewall rule base. So this is the 3-tier app, and I really did a bunch of typos here. So in the 3-tier application, you typically want to have, any source can talk to the web servers, because let's say that's your web server and all the internal clients are connecting to your web application. Yeah, you know, in the demo environment, going from any would be more than fine. But source any to the presentation server, that's allowed. Then going from presentation to the applications layer, that's also allowed. Going from application to data is also allowed. What you would typically want is, for example, prevent the presentation layer from directly approaching the data layer, kind of breaking your reference architecture or architecture model. So let's do that. So let's put in that layer of protection. So let's say block presentation to database. My source would be presentation service, of course. Destination would be the data layer, the data tier. And I want to drop this traffic. Now, I forgot to mention one thing. Given this is a demo environment, I'm not too concerned with the apply to rule or the apply to field. And the same goes here on the policies. So you would want to be careful with always using the distributed firewall is the apply to. This will give you scalability issues, but it also is less secure than specifically applying it to your security groups, for example. I won't go into too much detail because this video is already getting way too long. But yeah, look at the NSX design guide and make sure that you understand how to properly use the apply to field if you're doing this in a production environment. Okay, moment of truth. Let's put the last rule into drop. And let's publish this and let's see what happens. So now every traffic that's not being explicitly allowed by me, that's now being dropped. So let's see, and this probably will break. Let's see if our web server is still up and running. It is not. Let's check out the production server, which also has a problem. Let's fix this. So let's create a fix policy and let's create a new rule which says I want to allow incoming web traffic. So let's say my source is any destinations. I want this to go to the web tier and the presentation tier. So I kind of gave them confusing names. So this is my web tier, presentation tier for production, and this is my web tier for dev test. And I want to allow HTTP. Let's publish and see what happens. It's in progress. I think we have to wait. And now it's uploaded. And there it is. It's back up and running again. So we fixed the issue. Now let's do some basic testing. So let's, for example, try to ping from web server 1 to web server 2 in dev test. So this is 10.0.100.52. Let's launch a small console. Ping 10.0.100.52 is the own IP address. And 51 is web01 dev test. And this is running on the same network. And this is running on the same network. So let's even see, this is running on ESXi03 and web dev test 01 is running also on ESXi03. So this is a perfect example. These are two virtual machines on the same logical switch, so on the same web segment. And we successfully isolated these two machines from each other with a very simple rule. So here we said all the presentation servers are not allowed to talk to the other presentation servers. So that's it. Really simple, really easy. Let's do some other testing. We also have Web App 01 and Web App 02. So these are my production servers. 10.0.100.11. As you can tell, this is again running on the same segment. So 11 is not allowed to ping. 12 is also not allowed to ping. So we're successfully blocking traffic here. Let's try to see if we can traverse from the web server to the application server. So this is 10.0.101.51. Let's test that. Ping 10.0.101.51. That's allowed because, take a look at the rules. My presentation server. I made a mess right here. So this is why it actually broke. I need to drop this, publish that. And also let's disable this. Let's disable these rules. Publish. Yeah, so this is how it goes in real life as well. So, you know, we get a call, we get an incident. I made a change. My first task would be, okay, how can I quickly fix this and restore the service? So that was adding that emergency rule. Now, when I'm diving a little bit deeper into my rule base, I see that I made a mistake when I entered the, when I set the drop action on the wrong rule. So I actually dropped my any to presentation rule and I allowed going from presentation to data. So with this in place, let's do another test. Oh. Let's see if this is still up and running. It is, and the second is also up and running. So let's see if we can ping the database server. So let's go over and see if we can ping the database server from the presentation server. So this is 10.0.102. So let's test it. 102.51. This should be blocked. It is. So we are successfully able to go from presentation or from any client to the presentation tier, from the presentation tier to the application tier, and from the application tier to the data tier. Now watch what happens when I say that from any to presentation. Let's say that I only allow HTTP here. Okay, apply. So before we publish this, let's do a simple ping test. So let's ping 10.0.100. What is it? 10.0.100.11. And let's do it like this. Let's put this here, put this one on the side. And now let's publish this rule, because I'm now saying that I only want to allow HTTP traffic. So here you see immediately the policy is applied and all other traffic is blocked. Now I'm not really sure what I'm using in the other tiers, to be honest, in the demo application. I think it's simple Tomcat or anything, but yeah, for for demonstration purposes, I think this really this says it all, right? Now there are so many much more topics we could cover from a security perspective. Doing, this was all fairly basic, layer 4 stuff. So IP address service, but we can of course also do fully distributed IDS IPS, so doing advanced layer 7 stuff. We can do network traffic analysis, the new capabilities that were acquired from last line with the sandbox technology. So tons and tons of stuff. NSX is really becoming a very, very mature, feature-rich network security solution, but that would go way too deep for this video. It's already taken me way more time than I intended. Thank you so much for watching. Stay tuned to this channel. Don't forget to subscribe if you want to see more videos on NSX. Thanks for watching. See you next time.